The EDA industry has been a tremendous place to be in the last 50 years. The reason is really the same as any other exciting industry. It really consists of two things. One, exciting, tough technical problems to solve that make a real difference, that change the world, that change the way we do things. And the second part is financial growth and opportunity to start new companies, grow those companies, grow small companies to big companies. It's true today in social networking, biotechnology, but also semiconductor electronics and EDA. Well, probably no technical challenge or change has been greater than what's happened because of EDA over the last 25 years. With about a 3% per year growth in the number of electronic engineers, the number of transistors designed and produced has increased 5 orders of magnitude in 25 years, enabling products we never imagined possible. And with those technical challenges has come growth. An industry where our customers did largely manual design in the 1960s and well into the 70s, design it, build it, test it, and redesign it. Automation has now created a flow and an industry of over $6 billion. But you know, all good things have to come to an end. And we hear, Moore's Law, it's coming to an end. Even Gordon says no exponential can be forever. And yet, for a dying law, it's doing pretty well. You take a look at the percent of wafers with each technology node, and what you notice in the last 4 and soon to be another generation, that the slope of adoption of new technology has accelerated, not slowed. It's happening even faster. And if you look at the technology challenges we face today just to implement 20 nanometer, 14, 16, and 10 nanometer, we're undergoing one of the most disruptive changes that we've seen in years. A totally new transistor structure in FinFET. Design automation tools never had to worry about thermal analysis or stress in the past, and yet it's a major requirement now, as is reliability, electromigration, other things that now the designer has to worry about with tools from startups, from established EDA companies, and we really seriously need another 2 orders of magnitude in power reduction. Technical challenges that are coming as we follow this Moore's Law path. But there is something else very, very unique about the semiconductor industry that's different from others. Most industries mature. Steel, textiles, cotton, coffee, they all reach a point where their unit volume growth slows to single digits. Even more recent industries, cell phones and computers, are low double digits in terms of unit growth. Well, as we move beyond that Moore's Law era, that unit growth is what is going to create the next big wave of excitement, far bigger than the one we've come through. Because the transistor grows at 72% per year, unlike any other commodity in history, continuing a compound average growth rate far greater than any other of the historical growths of industries, that powers a learning curve. That learning curve is a log-log plot of the cost per unit versus the cumulative number of units produced. It's a perfect straight line. It is for every industry, but it is much more perfect and longer for the semiconductor industry because of that unit growth. Now, Moore's Law is merely a mechanism that has helped us stay on that learning curve for a period of time, but the future will continue as long as the unit growth continues. And incidentally, I'd like to point out that the EDA industry has stayed on an exactly parallel learning curve if you take EDA revenue per transistor, as it must, because if we didn't, then we would drag down the semiconductor industry and become a bigger and bigger percent of their revenue. So, what comes next? Well, when Moore's law makes it difficult or not cost-effective to shrink in the XY plane, we grow in the third dimension. We add layers. We build 3D devices. We do more functions per dollar by integrating photonics, by integrating mechanical functions or new materials, and stay on that learning curve with all that growth. Well, there are plenty of technical challenges, and they're exciting ones, but what about the economic growth? Well, the EDA industry thus far has been powered by the semiconductor industry, taking it from manual design of chips to automated design. And as that revenue for EDA grew, it flattened out at 2% of semiconductor revenue and has been at that 2% for the last 15 years, almost constant. It's a $300 billion semiconductor industry, so therefore it's about a $6 billion EDA industry. But the big thing yet to come is as the systems world adopts automation, and that systems world is right about where the semiconductor industry was in the late 60s and early 70s. Now we're talking about a $1.9 trillion industry, 2% of that, 38 billion, 6 times what the EDA industry is today. And that opportunity is real. The importance and significance of it was introduced to me by our keynote speaker today when in the early to mid 1980s, he, as the account manager at Texas Instruments for BMW, took me in to visit Herr Wolfgang Dr. Ziebart, who at that time was head of engineering for BMW. And Greg had the task of convincing BMW they should design digital signal processors into their cars. We visited him many times. Herr Dr. Ziebart eventually became CEO of Infineon, but while he was head of engineering at BMW, he did indeed not only design in digital signal processors, but was a leader in the wave of other electronics. Greg did his job, but the industry has expanded to the point where the bill of materials of an automobile today is almost 50% electronics. And just as the semiconductor industry didn't adopt EDA because they wanted to, they did it because the complexity became too great to do it manually. The same thing is happening in the automotive industry, and not just the automotive industry, it's happening in the systems business in general. Not just planes, trains, cars, but big systems, as Greg will address today, the Internet of Things, going from hundreds of millions of electronic components to billions of components, sensors, intelligence sensors, machine-to-machine communication, processing of data to solve the really big problems in the world. The technical challenges and the growth for the next 50 years are far greater than the 50 years we've come through. It's going to be a great, great time to be in a great industry. Thank you.